Sound design.
So what can an L-Acoustics M1 and P1 teach us about proper sound system tuning workflow? That's what I want to look at in today's video. So Scott Sugden at L-Acoustics was nice enough to send me a P1 to play with. So I want to do some videos with it before my little lease runs out and I have to send it back. So first I want to look at workflow, then I want to look at some common processes, maybe a main sub alignment and a main fill alignment. Let me know, comment on this video if there's anything else that you want me to test with the P1 that you're curious about. So first of all, I'm always trying to ignore things, right? So even though I saw a P1 M1 demonstration at Infocom a couple of years ago, I really wanted to ignore it. I don't like to have to bother myself with things that I don't have to worry about. For example, so why did I want to ignore this? Well, it seemed like maybe too complicated, too simplified. You know, in the L-Acoustics world compared to other manufacturers, it seems like the handrails go up a little bit, right? So that's good for keeping you from making mistakes, but it also potentially stops you from doing as much experimentation as I like to do. And so I really had to get into it to see what the philosophy is. So I want you to kind of keep an open mind as we get into these videos, because if you're like me, you're probably thinking, I'm never going to run into one of these in my life. And so that's why I want to make these videos less about, you know, doing a review and are you going to buy this, and more about what can we learn from this product to improve our own workflows no matter what products we use. But I will put a little idea into your head, which is I have no idea how much a P1 costs. It's probably going to seem like a lot when you first look at it. And so why would a freelancer like you or me ever think about buying something like this? I'm going to spend $1,000 on software, and I'm going to spend let's say $500 in audio interface, or maybe you're going to spend $1,000, but it's also the processor. The P1 is your microphone preamp. It is an output processor. And then the software comes for free with LA Network Manager. Okay, that's not the road we're going down. What we really wanted to look at here is what are some things about this setup that we can learn to improve our own workflows. Okay. So this is what you see in LA Network Manager when you open it up and you only have a P1 connected. Now this is not very common. Normally you would have a bunch of other stuff in the L-Acoustics network infrastructure, right? And this is my very favorite part of this so far, because if you've watched other of my videos and read my articles, you know that I am a big proponent of using a checklist and a map. Super important. I do one before every show now. Even if it's just a small show, a couple of speakers, I'm still going to draw on the map where I'm going to place my microphones, and I'm going to make a checklist of all the measurements I want to do so that I know what the purpose of it is. Because once I get in the field, I know that things are going to speed up, time compression is going to happen, I'm going to get nervous, I'm going to have 100 things to do, I'm going to forget what I'm doing, and I need to get this sound system calibration stuff done in 30 to 60 minutes. So, how does this help? This is just a blank space. Well, before you can do anything, you're forced to put in your microphone locations and basically give them a title and think about what their purpose is. Because if I click on M1 here, it says, no. You need to create some groups. I'm going to add a group here. Think of that as like a processing output. Okay? So what speakers do I have in my room? Well, this is the other interesting thing. I don't have any L-Acoustic speakers. At first I thought that P1 M1 combo was only for L-Acoustic speakers. And you do get some benefits, some small benefits, if you do have L-Acoustic speakers, that to me don't seem super significant. It's more about just capturing the data. So you can use them with other brands of speakers. So I have a JBL PRX 615M. That's my main speaker, so maybe I should just write main sub, and then I have a fill speaker. Let's call this fill. Okay, so these are processing outputs, but then I can add more processing upstream of that. For example, once I get my main sub alignment done, I might decide later that I want to EQ that as a group. So I might call this main sub, and then this would be upstream of that. And then I could add another group that is everything, so that I can do some, tonal balancing later on down the road. So this would be even upstream of that. And you can do this however you want, but you can make this like nice graphical interface to just help you remember where these things are in the room. Now I need to think about all of my microphone locations. And this is a little bit of a mind bender as well, because I'm going to put in 9 microphone locations, but I have 3 microphones. So location is just that. It's just a location. But you could use a single microphone and move it to 100 different locations. So I'm going to call my microphones on axis, off axis right, off axis left, just for my little setup in my office here. But I'm going to do 3 more at a shorter location and then 3 more at another location. All right, so now I have all my outputs and inputs, all my groups and locations. So let me just put them into kind of a place here in the playground that makes graphically sense to me. Commonly it won't be this situation, but for today, every one of these microphones is going to measure every one of these speakers. So I just need to add each of them like that. 1, 2, 3, 1, 2, 3. Okay, so just by forcing myself to make a plan here, I've already saved myself some time in the future by making mistakes of running around and redoing microphone locations that I screwed up before. So now once I have everything set up, I can open up M1. The next thing that we can learn about our workflow from the M1 is just the order that these tabs come in. First of all, you're going to record. That means take your measurements and make sure that they are high quality. Then you're going to do your EQ, then your crossover alignment. And so sometimes I notice that people are confused about whether or not they should do crossover alignment before or after EQ. And so this should help you remember that if you change the EQ, then you need to update the alignment. Now the way the P1 captures your measurements is really interesting. You're basically just going to tell it what you want it to do, and then you're going to hit start, and it's going to go through everything automatically. And if you have ever used a SIM3 or you've taken a SIM3 course, then you're familiar with this. You've probably seen other kind of integrations where the measurement platform is integrated with the amps or with the switcher or with the matrix or something, so that from the audio analyzer you can mute and unmute your outputs, and that's really nice. This would be really similar if you created some script or a macro to control, REW, SATlive, Smaart, Crosslight, to take all the measurements for you. So you basically tell it what you want it to do and you just hit start. In fact, all right, so I started with all of the minimum settings here, a single sweep, the shortest duration, and the minimum amount of gain. And I have my air conditioner on here in my room, so let's see how it does. Okay, so the first thing we see here is the signal to noise ratio. And we have a nice quality indicator down here that we'll see in a lot of other graphs that show us green for good and red for bad. And what they have defined as bad is basically anything below 15 dB. So I know these numbers are a little bit small here, so I'll draw a line. So anything below 15 gets a red color, and I think anything below 20 gets like a yellow color. So you can see that only in a few places here do I really get a green color. So what do I need to do here to get better signal to noise ratio? Well, I can do a longer sweep, I can do more sweeps, I can do louder sweeps, or I can try to reduce the sound in the room here. I could turn off the AC, turn off the fan, and things like that. I don't want to do that, and it's pretty easy to make these changes here. And I know I said this wasn't going to be a review, but this is where I'm going to start throwing out some ideas that I think L-Acoustics could do even more here, because they've done so much great research into exactly what these choices need to be. Because right now they all seem a little bit haphazard or random. Basically, I just need to keep playing with these until I get good data, right? Or until I run out of time. But from papers that L-Acoustics has published, we know some really important things, like we should have at least 8 measurements in a space to try to randomize the comb filter and get a really good characteristic of the space for EQ to reduce our risk of error when we're EQing. And they have some really specific guidelines around that. And I would love to see that actually represented in this space here. It could say things like, hey, you only have 2 microphone locations. Wouldn't you like to do 8? Or something like that. And then over here, they also have some research in AES papers that they've published that says that you should be taking 8 sweeps. If you are outdoors or in a noisy environment and you're measuring low frequencies, use at least 8 sweeps. And it seems like they could put that in here as well. If it says subwoofer, or you can characterize the speaker as a low frequency driver somehow, they might just automatically choose that for you or recommend that for you. Anyway, I would like to see some more guidance around that, because otherwise you kind of get to this section and it's not quite sure what the best default is to start with. There is in fact a default, and maybe that is the best, but I wanted to show you here that it is possible to get a bad measurement here and have to redo it. So let's fix this. So I'll throw this out, and let's start by going up to 4 sweeps. Now, why am I doing this? Well, I basically want to learn what is the fastest way I can do this and still get high quality data. So you see here that I still have some missing things here. So I'm going to need to keep going. So now I have 4 sweeps. So let's try 4 sweeps and a longer duration. Okay, it's better here. And so I still have a couple of areas here where it's not quite getting into the green. So I'm going to throw this out. And what's the one thing I haven't changed yet? It's the gain. So I'll bring the gain up a little bit. Now, if I didn't want to bring the gain up, because I'm in a situation where that might bother people, then I could change the duration or the number of sweeps. So let's bring the gain up. All right, so I've got, 99% green here, so I can decide now if I want to keep playing with this or just move forward. It looks like I have pretty good data. The nice thing is that now that I've figured out some settings that will work with these measurements, I can just pretty much set them all to the same thing. They are different speakers, but I have a better starting point now. So the third thing that I'm learning here from the P1 M1 workflow is that it's really important to make sure that I have high quality data. And it has some things here to help me do that. So it has this dotted line to show me signal to noise ratio. It has like this quality bar down here. And there's also some text over here, and it says, hey, on this orange guy, the signal to noise ratio was just too low. So it's been excluded from the average here. And so I can see what happens if I include it or exclude it, and that changes the average, and it changes the signal to noise ratio. Now I think it's actually improving it a little bit, because the average is going down over here, which it should, because there's no signal down here. And I have a better green bar. So I'm going to throw that one back in there. So this is the same thing we would do in any other audio analyzer. So in Smaart, we'd be looking at our coherence, we'd be looking at our live IR to make sure that's lined up properly. We'd be looking at the ripple, and probably the most powerful thing we can do is actually make a comparison to some known quantity, right? So we want to do the meet the speaker step, where we go up close, take a measurement before the room gets involved. What happens when that single speaker gets arrayed with a bunch of its brothers? What happens when a bunch of reflections get involved? And the only way we can do that is by either getting close up and personal with that speaker in the field, by getting up on a ladder or a lift or something, or we can download the manufacturer's spec sheet, and hopefully they have a GLL file, and then we can export that and import that into our audio analyzer. Or we can use Tracebook. So hopefully you guys know that Tracebook is a new project I've been working on and I launched recently, and that is a place for you and I to share this kind of actionable loudspeaker reference data, so that we can do this work of comparison in the field, so that when I take a measurement like this, I can say, am I correct? Am I doing this correctly? Is this speaker operating as the manufacturer intended it to? Or that's not the only use for Tracebook, but that's definitely one of the most powerful ways that I use Tracebook. So I would love to see L-Acoustics incorporate something like that in the future, because they have all the data. So if you are using L-Acoustics products and now you're using a P1 M1, it would be so amazing here to just be able to click a button or to have it automatically load a trace. So if I'm measuring, I don't know, Cara, and I measure a Cara array, I would love to just be able to click a button and see a template of a Cara. So I can just do a verification procedure and see, like, is there anything way out of the ordinary here that I should be aware of? Because otherwise I'm looking at this data and I'm saying, yeah, I guess this looks good, but I really don't know. So in future videos, I'll talk more about how we can do this verification step in these other tabs. But here, as far as I can tell, there's no way to compare anything because we can't look at two measurements at once. I can look at this one or I can look at this one, but not both at the same time. So I'm going to go through and just approve my data. Phew, okay, that took some time to capture all that data, but the cool thing about the workflow here is that I never have to do this again. Unless I made some big error here and, had the wrong inputs connected to the wrong outputs or a broken microphone, which is a possibility, which, by the way, is why you should be listening to your microphones through headphones before you take these measurements. And I think I saw a headphone jack on the front of the P1, so there must be some way to do that. So yeah, unless I screwed these up in some big way, I never have to come back and do this step because the rest of the process will be done virtually. So that's the other big thing that I learned from playing around with this system. If you know exactly how your DSP is going to perform and you know exactly what the filters are going to do, then there's really no reason to remeasure after you insert the filters. So if you're using any audio analyzer and you don't have integration, with your control platform, it's just whatever you have that day, then you don't really know, right? I don't know. So what we typically have to do is we take a measurement, we make a change, and then we measure again to make sure that it actually turned out the way we wanted to. Or you're just constantly measuring in real time and you're watching the measurement update as you make that change. And that can be really nice, but this kind of eliminates that process. So now I've done all the noise I need to do in the system. So let's say I just did, 20 minutes worth of noise, and now I don't need to do any noise. In fact, I could turn the sound system off as I complete the rest of these procedures. And you could do the same thing with any platform that has some kind of system simulation or virtualization. So for example, you could take all your measurements in REW, Crosslight, SATlive, FIR capture, those kinds of platforms, because they have built-in like virtual EQs, virtual crossover filters, delay lines, and things like that. All right, so I'm going to save this session file, and the cool thing is that you should be able to open this up on your end. So I will put a link to where you can download this file somewhere in the description for this video. Okay, so now we're getting into the EQ tab, and the next thing I'm learning here from the process is that although it's pretty easy to just turn on an average of every one of my measurements here that I took of this fill speaker, for example, I might not want to do that. Because as I'm remembering, there were some of the measurements that I actually took from behind the speaker. So here's what a measurement looks like in front of that speaker. Okay, so we can see a lot more high frequencies here. So I might want to look at this average and then maybe throw out this one that was made from behind the speaker. The next thing I'm learning here is that these averages are definitely influenced by the level coming in. So it doesn't average all of the levels to the same area first and then find the average, and I'm not sure if there's any way that I could do that anyway. So I love that there's a target trace built into M1 here, and it just comes with this default setting, and there's a way to edit it. And I would love to see more of this. I think it's only in SATlive does it have a built-in target trace editor. Now there are plenty of other places where you can easily import a target trace, and REW is probably the easiest place to do that because you can just create a text file literally with two numbers that says start at 20 hertz and end at 20,000 hertz and put two numbers in there and it'll fill in the rest of them for you. But it's still really nice that it's so easy to get a target trace going here. Now, probably everyone would hate this, but I heard a really great tip on an L-Acoustics video yesterday. The number of EQ filters available compared to the number of measurements you've made. So if you've only taken a single measurement, you can only use a single EQ filter. And so if you want to use more filters, you need to take more measurements. So I've taken a bunch of measurements here, and so it would be cool if it just like turned on the number of filters. You know, I've taken 9 measurements, so it turns on 9 filters or something like that. I think that would be pretty cool. It's also interesting for me that there is no auto EQ function. And I think the reason for that is that it's traditionally something that's not considered professional. And so although I suppose sound engineers would accept or really appreciate an auto align function because the phase graph can be scary, for some reason there's no auto EQ. And as you've seen in other videos that I've worked on, we have some automatic EQ filter suggestion in places like REW and Crosslight, and I find that can really be a time saver when I know exactly where I want to filter, but I don't know exactly what the width needs to be or exactly, you know, all the characteristics. And so if I can just tell it, hey, like fix this in this area, and then it makes some suggestions for me, I find that to be a real time saver. So here, as I'm inserting this filter, you know, I'm going to be taking it in and out. And it's nice that it has the transfer function of the filter here, but unfortunately, they have not inverted it. So that would be another option, and I'm not sure if that's available. Maybe it's just an option I didn't know about. It'd be really nice if this was inverted and then I could draw on top of this peak. And probably the other thing I'm missing here is just the ability to drag and move this with the mouse. So ideally, I would draw this on top of the peak, and then I could just zoom in here and grab this and move it right to where I wanted it. And I have to tell you guys that when I first opened this up and I saw a button here labeled phase, my eyes almost fell out of my head, because I don't think I've ever said it publicly here in a video, but I've said to friends of mine and colleagues, like, L-Acoustics doesn't care about phase. You can't look at anything about phase in Sound Vision, and they just try to pretend like it doesn't exist. But now I have to eat my words, because here it is. Here's the phase graph. Now I can compare phase traces between these two measurements and or look at the impulse response, and I can zoom in down there. But another cool takeaway from the workflow here is that if I've decided on an alignment that I like, and I go back over here to the EQ tab and I look at a sum between two measurements, I'll see those changes reflected here. And I see here, oh, there's delay now on this sub. And I wish it also said that there's a polarity inversion here, but I guess you can always just double check that by heading back over here. Now, once I see this, I'll also be clued in if I go to, say, my sub measurement and I make some changes to the EQ. So if I take, you know, one of these filters out, let's find a big one, maybe this one. There we go. That might, now I can see that that is going to have some change on the crossover alignment for better or for worse. And so if I make some changes in the EQ on these solo elements, I'll know that I need to head back over here and work on my alignment. But I can still, now that I've done the alignment and I've set a thing here, I can go upstream on my main plus sub, and now I could insert some EQ on this whole thing. And let's say that I wanted to have a low shelf and start that at about 125. Now I can apply that to this group as a whole. So as I'm going through this process, it is showing me a simulation of these filters, but it's also applying all of these filters in real time to the processor outputs. So I'm going to save this, and then if I go over to my processor here, I believe it's on the outputs or the bus here. There we go. I can see the EQ changes, the polarity inversion, and somewhere in here, there it is, the delay that I applied. So all this stuff has already happened, and I suppose if you wanted to, you could go back into record and record again and double check that all this stuff has actually taken place, but it's really not necessary. At this point, you could move on to the toning phase and, you know, do your all EQ here to just adjust for that total spectral tilt. So these are some of the things that I've learned by just playing around with the P1 and M1. I hope this was helpful for you, and I hope you'll let me know some of the things that you've learned by playing with the same thing, especially those of you out there who are L-Acoustics users and have had some time in the field to use the P1 M1 process. Please comment on this video and let me know some of the most helpful things that you've learned. All right, thanks. Sound design.